today we're going to learn how to solve quadratics and cubic equations, and I'm going to take you through the notes from class. So if you're absent, you definitely want to watch this. All right, so the steps for solving for a quadratic, and let's just kind of look and see what these look like. So you can see you have parentheses, and inside the parentheses you have an expression x minus 3 squared. The first step is to isolate whatever is being squared. So sometimes it's in parentheses and sometimes it's just an x being squared. Then step 2 is going to be to to take the square root of both sides, and don't forget to use the plus minus symbol, and I'll show you how to do that in just a second. And when you isolate whatever's being squared, I meant to remind you this is reverse PEMDAS. Okay, so step 3 will be to finish solving, and that involves a couple of different things, but first and foremost you have to isolate the x inside the parentheses. So you're going to isolate the x, basically solving for x, okay? And again, you use reverse PEMDAS inside the parentheses as well. So you may get no solutions, no real solutions. You may get one real solution, or you may get two real solutions. Okay, so 0, 1, or 2 solutions. All right, so let's do a problem. So the first thing I'm going to do here is add 4, and when I add 4, I notice over here I get a perfect square of 64. That'll work out nicely for me. And I'm going to take the square root of both sides, and when I do that, this root of 2 cancels this power of 2, and don't forget to take the square root on the other side and use your plus minus symbol. So I'll kind of tidy this up a little bit. So I end up with x minus 3 is plus and minus the square root of 64, which is 8. And now I need to finish solving for x. I'm going to add 3 to both sides. Now I end up with 2 different equations here, very similar to what you get when you do the quadratic formula. So I have a plus 8, a positive 8 plus 3. I'm going to write it like this first, though. So I'm going to have 8 plus 3, which is 11, and then I have a negative 8 plus 3, which will be a negative 5. So my solution to number 1, there are 2. It's 11 and negative 5. All right, let's do another one. I'm going to add 36 to both sides, and when I take the square root on the right side, I end up with plus and minus 6. And then over here, when I take the square root of all this, I end up with 2x plus 3 is plus and minus 6. So let me kind of segment this off. So what I'm going to do is isolate this x right here. So I'm going to subtract 3 and then divide by 2. So let me show you what this will look like. I'm going to have plus and minus 6 on the right side. I need to subtract 3 and divide by 2. So I end up with, something that looks very similar to what you would get out of the quadratic formula. So I have 2 different equations here. I have 6 minus 3, which will be 3 over 2. And then I have a negative 6 minus 3, which is a negative 9 over 2. And these will be my 2 solutions there. Okay, let me go to the other type of problem, because number 3 is very similar. Let's go to the next type, which is solving cubic equations. Very similar process. The first step is to isolate whatever's being cubed. Could be just an x being cubed. Again, use reverse PEMDAS. And the reason I keep saying this, guys, is because students struggle with what to do first. You always add or subtract first, and then you multiply or divide. And very often it's dividing. So I just want to reiterate that. Step 2 will be to take the cube root of both sides. And I do not need a plus minus symbol here. And it's because of the shape of the quadratic versus the shape of the cubic. And then step 3 will finish solving for x, and you only get one solution. And you will always get exactly one real solution for these. So I just want to tell you about that. Okay, so let's do this first one. Now, the cube root is a little bit different than the square root, because the square root you're looking for a number times itself that gives you, say, 16, for example. You know 4 times 4 gives you 16. When you're looking for a cube root, you're looking for a number multiplied 3 times that gives you 8, for example. So 2 times 2 times 2 will give you 8. So since 2 cubed is equal to 8, the cube root of 8 is equal to 2. So that's what this means. It's very similar to when you take the square root of 16, you get 4, and that's because 4 times 4 is 16. Here, you're looking for something multiplied 3 times to give you a value. And let me just remind you, you can take the cube root of a negative number. So for example, the cube root of negative 8 is just going to be a negative 2, because negative 2 times negative 2 is a positive 4. Let me write this out because it's kind of hard. And once I multiply that positive 4 times the negative 2, I get a negative 8. And there are my 1, 2, 3 negative 2's being multiplied. All right, so I'll do some of these and hopefully that'll make sense to you. So the first thing I'm going to do is take the cube root of both sides because it's already isolated. This in parentheses is already isolated. So take the cube root here. The root of 3 and the power of 3 cancel. And then the cube root of 8 is 2. So I end up with x minus 3 is equal to 2. And then just add 3, and you get x is equal to 5. So in some ways, these are a little bit simpler because of the fact that you don't have this two equation, like 2 solution thing to deal with. All right, so the next one is we're going to isolate this x plus 5, all cubed, all this, so I need to divide by 2. So divide by 2, and I get 27. So x plus 5, all cubed, is equal to 27. I'm going to take the cube root of both sides, and that clears out this cube there. So I end up with x plus 5 is equal to, and the cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27. And then just subtract 5, and you end up with x is equal to negative 2. So again, one solution. Okay, the next one, divide by negative 2, and I end up with x plus 3, all cubed, is equal to a negative 8. So I'm going to take the cube root of both sides, I'm going to isolate that off, and I end up with x plus 3 is equal to a negative 2, because I'm cube rooting the left and the right side. So subtract 3, and I end up with x is equal to negative 5. And that is my one solution. Okay, now the next part is mixed up, and that's intended to make you look at whether you have a quadratic or whether you have a cubic and sort of go back and forth between the 2 different processes there. But again, they're very similar. Okay, so this is a quadratic. So I'm going to isolate this inside. So I'm going to start by adding 2 to both sides. And I end up with, I'm running off the sheet here, sorry about that. I'm going to end up with 3 times x minus 3, all cubed, is equal to, and then I have 36. Okay, so I kind of scooted over there. But just bring down the 3, bring down all this. All I did was get rid of the plus 2. I added 2 to both sides. So this is gone. Then the next thing I want to do is divide by this 3. This is a square, guys, not a cube. Is equal to 36. So then I divide both sides by 3. And then this will cancel. The 3's will cancel to a 1. And then I end up with x minus 3 all squared is equal to 36 divided by 3 will give you 9. Okay? I'm sorry, 12. I was looking at the wrong thing. Okay, now the next thing I'm going to do is take the square root of both sides. So square root of the left, square root of the right. Don't forget your plus and minus. So I end up with x minus 3 is equal to plus and minus the square root of 12. Then I add 3 to both sides. Now, you remember, I cannot actually add the 3 and the square root of 12. I have to keep them like separate. So I'll have x is equal to a positive 3 plus and minus the square root of 12. So this should look something like what you would get from the quadratic formula. I want to put it in that form. Now the square root of 12 will simplify because I have 4 times 3 and I can take the square root of 4. So this is going to simplify to 3 plus and minus 2, because the square root of 4 is 2, root 3. And that would be your solution. And there are 2 solutions there. And you can leave them just like that for this one because you really can't combine these into down to a rational number. So that's giving you two irrational solutions. So kind of referring back to last part of the unit. Okay, let's look at the next one. It is a cube. So I need to isolate x minus 3 all cubed. I'm going to do that by multiplying both sides by the reciprocal here. So multiply by 2 over 1. So it cancels down to a 1. So then I have x minus 3 all cubed. And then, of course, I have to do the same thing on the right side. And I get an 8 on the right side. So then I take the cube root of both sides. I'm going to section this off. And then the cube root will cancel. The root cancels the power of 3, and then do the same thing on the right side. And I end up with x minus 3 is equal to 2, add 3, and you get x is equal to 5. And there's your solution. Okay, let's do another one. I'm going to isolate the x plus 5 squared. So this is a quadratic. So I'm going to get, two solutions maybe. We'll see. I'm going to add 18 to both sides using my reverse PEMDAS. So I get 18 on the right side. This will cancel. I'm going to now multiply both sides by 4/3. So 4/3, clearing out that fraction. So the 4 and the 4 cancel to a 1. The 3 and the 3 cancel to a 1. So I'm left with x plus 5 squared is equal to 18. Okay, of course I have to do the same thing on the right side too. So I'm going to end up with 4/3, and that will give me 24. So this is going to be 24. So sectioning this off again, x plus 5 all squared is equal to 24. And I just do this in your calculator. Or 18 divided by 3 is 6, and then 6 times 4 is 24. Then I take the square root of both sides. Don't forget your plus minus sign. So then I end up with x plus 5 is equal to plus and minus. And the square root of 24 can be simplified because 4 is a perfect square. So the square root of 4 is 2. So it would have been 4 times 6, but then I can take the square root of 4, simplifies to the 2. Then I subtract 5, subtract 5. I'm going to write my answer like this. X is equal to negative 5 plus and minus 2 square root of 6. So again, I'm getting two irrational solutions here. Okay, let me do this next one, okay, because it has like a different outcome. I'm going to start by dividing by 4, because there's nothing to add or subtract. Divide by 4, and I get a negative 9. So then that's going to simplify down to x plus 5 all squared is equal to a negative 9. Now, when I take the square root of both sides, I end up square root, and remember the square root of negative 9 is a 3i. So I end up with x plus 5 is equal to plus and minus 3i. Then I subtract 5, and I'm going to write it the same way, negative 5 plus and minus 3i. So here I actually have no real solutions. I do have two imaginaries, but no real solutions. Okay, and let me show you why that's the case. I'm sorry, I ran off the page there. Okay, so that's the answer to the last one. So this is why sometimes there's two solutions for the quadratic, sometimes there's no real solutions. It's because of the shape of the quadratic. So I could have a quadratic, for example, that opens up like this. It doesn't cross the x-axis at all. I could have a situation where, if you remember, a perfect square trinomial gives you a double root gives you two of the same number. So there's one real solution. It's called a double root. Here, there's no real solutions. And then I could also have the scenario where I have a graph that crosses twice. So that's where most of these two real solutions are coming from. Sometimes there are two rationals, sometimes there's two irrationals. The cubic function, though, no matter where you put it, shift it, translate it, reflect it, whatever, it will always cross the graph exactly one time. So always have exactly one real solution. It may be irrational or it may be rational. You just don't know until you solve for it. But that is today's lesson, and just work on doing the homework, and we'll check it tomorrow.